Okay, quick video. Breaking the equivalence principle. All right. Equivalence principle says if you're in an elevator with a rocket accelerating 10 meters per second squared, you can't tell the difference if you're on a planet with 10 meters per second squared acceleration. This is just not true. This is one of the most silliest things, or overanalyzed, overextended. Anyways, I'm going to show you really quickly 2 ways where it's just totally broken. It doesn't work. Okay, first way. If you're on the planet in your elevator, and you're in your rocket ship on your elevator, you will experience, on the planet, you will experience what's called tidal forces. Tidal forces. And all that means is that your clock up here, if you move your clock up to the top of the elevator, it will go more slowly than if it was here at the bottom of the elevator. And that's just because you're further away from the center and the escape velocity is a little bit different. If you're in the rocket, the clock will run at the same rate no matter where it is in the elevator. Easy test to figure out whether you're in an elevator or a surface of a planet. Okay. The second way to break the rule also involves clock, or is to let's go for three people in elevators. Again, you just take, now this one, you just need to be able to see the clock of the other person or have it transmitted to you. If you are in a first elevator, your clock on a first planet of radius r and mass m1, you'll have a clock rate 1, okay? Clock 1. And if you're in a planet of radius 3.3 and mass 10 m1, m2 equals 10 m1, 3.3 radius 1, radius 2 equals 3. You will also have the same acceleration. Well, let's just call it 10 meters per second squared. But your clock will run differently. And if you can see the other person's clock and compare it, you will see that your clock is not running the same rate as the other person's clock. And so you will know that you're on a planet, okay? Because your clock, you're experiencing fixed gravity, and your clock is a fixed difference. Okay, just going over it again. The clock for clock 1 will go at a different rate of clock 2, and the difference between them will remain the same for over time. So you will know that you're on a planet. If you're on a rocket, this person's clock will, looking at the other clip, this person's clock will not only run at a different time, but the time will change as this person accelerates, and the difference in speed between the two becomes greater. Not to mention the fact, so you'll see a changing difference between his clock and the other two clocks. Well, these two clocks will be fixed. Not only that, there'll also be a Doppler effect. So this clock will actually run slower or faster, depending on whether your velocity is closer or further from them, whether this rocket is coming at or away from them. so this will happen in addition to the changing difference in the rate of the clocks. So this is another way to see that they are not equivalent. The rocket acceleration will have different characteristics than the planetary acceleration. So that's it. So this shows you that Einstein's principle of equivalence is really imperfect at best and has a lot of issues at worst.